for Suyash, Dimitri, and other organizers for setting all these event pages up. And I guess we will wait for a couple of minutes before we officially get started in 1:05. Okay, thank you. Okay, thanks everyone for waiting. How about we get started now?
Sure.
Okay. Sure, okay, great. So, okay, thanks everyone for coming to our Woman in System episode number 3. And today we are very, very honored and to invite Professor Natasha Brook. She's a professor in UC Berkeley in the Data System and Foundation Group. And she is also a lead research consultant at Improbable in the UK, a founding member of Skylab in the UC Berkeley, and a member of Berkeley Center for Decentralized Intelligence. She works at the intersection of distributed systems, databases, and distributed computing. And she is generally interested in designing new primitives and systems for the large-scale geo-replicated storage systems that underpins modern applications like Amazon and Facebook. And she has won several great awards like James Gray Doctoral Dissertation Award, Honorable Mention, Google Research Award, Best Dissertation in the Field of Operating and Distributed System, ACM SIGOPS, etc. She's also the VMware Research Faculty Awardee. So on the industry side, she also has a very strong background and diverse experience. In addition to her current advisor role at Improbable on the Metaverse project, she recently was also a strategic advisor at Astronomer, and she previously worked at Materialize, a new streaming SQL Materialize view engine, where she remains a technical advisor. We are very impressed to see her diverse background and also solid contributions to the system community. And in our episode, Dimitri and I will be interviewing Professor Natasha on several diverse topics, including her past geographic experience, research choices, and she will also shed some light on her advices about managing relationships in terms of research and career. So, Dimitri, why don't you start with introducing yourself and a little bit about our event. Thank you. She will also shed some light
Hi everyone, my name is Dmitry Ustugov, and I'm an incoming faculty at Nanyang Technological University in Singapore. This December I'm starting, and at the moment I'm at ETH Switzerland right now. So I'm delighted to participate in this podcast and this series of women in computer systems. So here we invite renowned and rising stars in systems research to share the insights they have for the broad audience. Welcome, Natasha.
Thanks, it's super cool to be there.
Yeah, thanks, Dimitri and Natasha. And now let's move on to our first topic. So we've noticed, Natasha, that you have had a very diverse background in both French law and computer science degree during your undergrad at University of Cambridge. So we were curious, how did you choose to pursue these degrees? And could you share with us some of your thinking processes when making these choices?
Yeah, so in England, you start law at undergrad. So it's not like in the US where you go to law school. In England, if you want to do an undergraduate degree in law, you just do an undergraduate degree in law. And I'm half French, half British. And so I applied to a degree in British and French law. And I would have spent 2 years in England and 2 years in France. So this was the perfect degree for me. And I always wanted to work in sort of international relations and that kind of thing. And so that's what I applied for. That's what I started studying. But what I realized is that the degree was specialized in commercial law, which wasn't what I was interested in. And the other thing I had been interested in studying was computer science. And so Cambridge gave me enough flexibility to switch. And I had always been interested in doing, tech law, computer science and law, kind of policing that kind of intersection between law and computer science, and I still am. But people say that law and computer science are very different, but they're kind of very mathematical. It's in some ways you're kind of writing proofs in both cases. Like a distributed computing proof is kind of the same as a law essay sometimes, because you're trying to find all the possible scenarios in which something could go wrong, and you're trying to provide evidence that it won't go wrong. So if you're using a protocol or case law, the reasoning is kind of similar, which is what I kind of like. So it feels less different than it seems.
That's interesting. You also have quite a lot of experience both industry and academia. So it seems like combining something not so combinable from the first side is one of their strengths, probably, or differences.
Honestly, in terms of law, I just couldn't make my mind up. I would like to pretend there was a big agenda, but I just couldn't make my mind up between it. I think in industry, what's nice about being in systems is that a lot of the work that we do is directly applicable or directly relevant to industry. And so it was nice to delay Berkeley for a year so I could work in a startup, so I could actually have some industrial experience and discover what the other side thought was important and the other side valued. And trying to continue doing that at Berkeley has been nice as well, just to see what industry values and what they think is important, what are the constraints. I think I've learned a lot from being there and being surrounded by people who have different, I guess, thought process, values, and constraints than we do.
Yeah. That's actually quite true, and probably there is quite a lot of transferable knowledge, like from both ways. So.
Yeah, absolutely. And being in the Bay makes it easy. Well, I guess COVID made it easy because everything went on Zoom, but being in the Bay does make it a little bit easy. And a lot of universities will allow you to consult for a day a week, roughly. And I definitely don't spend a day a week on it, but I think it is a nice opportunity to do it. I mean, let's be honest, money's nice. We're all recently graduated, or it's nice, but also I think it's a good learning experience to do it if you can. And usually universities are quite good about giving you enough time that you can spend a couple of hours or a few hours a week doing that. And I certainly found that more than the money, I've learned a lot from it, which has been good.
So would you advise like assistant professors to actually shave off some hours to do a service like this, like besides the money, of course?
I think yes, if you get something out of it. So I think I made some, like there were consulting gigs that I did, which I learned a lot for, and I felt useful, and I learned a lot. And there were others where I was basically a glorified engineer, and I wasn't the right choice for them. And it wasn't the right choice for me, because if you have me a day a week to code, you should be just getting a full-time engineer. I'm not a better coder than the other 30 employees that you have in your company. I'm not necessarily bringing something to the table. So I think what's important is to choose the right gigs, and the ones where you actually either trying to develop a skill or whether you think you can really be a value added. Some people say that like consulting fees for professors are wild, but the point of consulting is that you can tell them in 20 minutes what they would have taken 6 hours to find out. And we all have unique expertise. Like whatever your PhD is on, you've read everything there is to know about it. You've thought for it for days. And so your value added is, if you ask me about Byzantine fault tolerance, for example, it's surprising how easy some of the answers come to me compared to people who have to learn the entire space. And it's not because I'm smarter, it's just because that's my area of expertise. And so I think the thing that I discovered from consulting that was important is, if it's going to take me 20 minutes to tell them, or like an hour, I can save them 6 hours of their time or 8 hours, then that's a good consulting gig. Otherwise, it's too much on my time.
Sure. And what about the other way around? Does it add something to your research about, on top of conferences and, regular visits from companies?
I think it does. I think it's good to learn about current practices, current constraints. So for example, when I was an astronomer, there were some conversations that where certain decisions were made because of legal reasons or because of commercial reasons that didn't necessarily make sense technically. Or when I was a materializer, I learned a lot about the prioritization, how it worked, where some of the features were developed because our first customers wanted it. At some point in Microsoft, I remember a lot of the PhD students and I were surprised about how the code was architected. And one of the reasons why it was architected that way, which wasn't the most efficient way, was because it was a large open source project and modularity was more important there than it was even for a closed source project, because there were so many contributors. So there were always a lot of things that I picked up on from the various things that I've done, which have definitely been useful. It's also just a way to build your network. Even if the actual hours that you spend aren't necessarily the most useful, it's certainly good to build your network, good to build relationships, connections, and to see other applications of the technology or the science that you've been doing.
Mm-hmm. Yeah, these are really great insights. Thank you so much for sharing, Natasha. I think when we are choosing to add a industry job or role, it's good to think about, okay, what are the values we can add to that company, and in turn, what we can learn and what kind of connections we can build. These are all great suggestions. Really appreciate it. And next part, we'd be curious to learn more about your experience because you have studied both in European and also in the US. Did you find any differences as from a researcher, a student, or from a professor's perspective?
So I think from a PhD student perspective, PhD students in Europe are treated more like adults than PhD students in the US, in the sense that when I was in the UK where I started my PhD, people kind of, my advisor was like, well, you know what you're doing, you're in PhD now, you're a PhD student now. I trust you to find something. And it was a bit strange when I came to the US, when I transferred after 2 or 3 years in Europe, where suddenly I had to take classes again. And my advisor was very much more involved and telling me what to do. So I think the UK process was much more independent, which can be a good and a bad thing. For a lot of people, I think it's too independent and end up, they would benefit more for a lot of structure. The PhD program in Europe is also, and I'm excluding EPFL, ETH, and some of the more American style programs there. But a lot of the PhD programs in Europe are 3 or 4 years, which means that they expect you to have a master's. Now that can be nice. If you don't want to go into academia for your PhD, you still get to learn a lot, but it's not quite the same time investment as in systems 6 or 7 years. It does mean that afterwards you'll have to do a postdoc, whereas it's a nice feature of the US PhD, then not always, but in most cases you can kind of avoid, you can apply for faculty straight away and you don't have to do a master's. So if you're interested in stability in your life, 7 years in one place might be better than 2 years in one place and 4 years in another, and then another 2 years in a third place. In terms of faculty, I think it depends on the schools. The more US schools like ETH, EPFL, MPI in Germany, I don't think that they're noticeably different from US schools. I think that the people who apply are a little bit different, so you'll get a lot more people from obviously Europe, Iran, Eastern Europe. I found that MPI, for example, was very diverse. So there were people from all over the world, maybe more so than in the US. There were certainly not many Americans, and there were a lot of people from South America. There were a lot of people from pretty much all of Europe. A lot of people from Iran as well, specifically Iran because of the difficulties of visas that they face with entering the US. So I think the type of people that you'll see are different, which means that if you're traditionally been in the US, identifying good PhD students will require more work on your part, because now you'll have to actually do some additional work in interviewing them, finding out what their background is, how this translates to something that you're familiar with. Because there's more diversity, I think it's an additional challenge that you have to be prepared to face. I don't think the students are different, but I think they might be. You'll have to do more work on your part as opposed to just being relying on what you know. I think for other programs like in Germany and in France, the education system is a little bit different. So it's less assistant professor, like there's less of that background. So if you're interested in applying there, then I think it's good to talk to someone from that region. So if you're interested in going back to Germany, for example, going to Germany, then talking to someone who is from that country or who is working in that country will be a good start, because the equivalences aren't necessarily the same. Likewise for France and likewise for Spain or Italy.
Yeah, it's actually quite true. I applied, I was on a job search market last year, and I had quite different experiences in different countries. But at the same time, I noticed that many countries do move to tenure track system, like for example in IST Austria or TU Munich. So there are quite of intersection. Same for Asia, for example.
Yeah, it's definitely moving towards a more unified system.
I would like to ask a question about what you mentioned, like differences between advising in the US and in Europe, for example. A lot depends on the advisor, right? Like whether there is more or less micromanagement or like high-level picture, high-level advice. Do you find this is there a clear trend on how people look for advising in these countries, or it's just, you know, people particularly? What kind of an advisor are you actually? European or?
You should ask my students that. I think there's probably trends in terms of expectations. So I do think, for example, in the UK, you're expected to come in with a rough idea of what you want to do, a rough topic you want to study. And then because it's 3 or 4 years, you know, you're probably more likely to be working on your own, and you kind of need to get started right away if you want to finish. In the hours of time, I think it's usually the same in France, for example, and most other places in Germany for a 3 or 4 year PhD. If you've got a 6-year PhD ahead of you and you don't have a master's, then the expectations on knowing what you want to do or even expecting that you've already got research experience are much lower. So I think in the US, it's much more common for first-year PhD students to work with a more senior PhD student for their first project. And their first project, you know, may or may not be related to their thesis. One of the junior PhD students that worked with me sort of worked on transactions and privacy, and politely told me after a year that he never wanted to do this again, and he never wanted to touch privacy again. But, you know, he still got whatever, the OSCI paper, second author, that he still learned a lot in research. He was still happy for the experience. He just didn't want to continue his PhD in that. And we still worked together, and he just went back to regular large-scale data processing systems. But the first project didn't really matter. It was just more of him getting warmed up. I don't think this is necessarily something that you can do as easily in Europe. And Europe, again, like excluding EPFL and ETH, where you have a much more US-centric system with a much more similar pattern to the US. So I think that is probably a broad trend. The size of the groups may be a broad trend. So I think in Germany, for example, it's more common to work with a postdoc than it is to work with the senior advisor, the senior professor, who tends to have a bit of a hierarchical structure where postdocs are more senior than postdocs in Europe, in the US. So they're basically assistant professors. But the official professor has a large group, and so you don't necessarily see him or her that often. I think within the US, it depends so much on the style, and I think I enjoy being involved, but I also have fairly young PhD students still, which makes sense because I'm 3 years in, and already I can see myself becoming less involved with some students because, you know, you sneeze and suddenly they come back and, oh, I have a project, here's the implementation. You were too busy doing something else, so we didn't want to wait for you. So I think it depends. And I'm not sure what my style. I think I like being involved. I still miss the details. Like I miss thinking about things, and so I enjoy being involved, but I don't think I go down to the level of micromanagement.
Yeah, that's great. I think having a balance about getting involved in a PhD's career path and also giving them more freedom to explore the things they want to do is always something an advisor and the PhD students need to work out. And thanks for sharing your experience and insights. And now maybe we can move on to our next topics, because Natasha, you are in this super exciting field, and also you are a founding member of Skylab in Berkeley. So we'd like to learn more about your research visions and your research experience in general. So as we all know, like distributed system, or this research is arguably one of the most challenging areas to study. And I was wondering, how did you arrive at choosing this topic in your PhD? And is it difficult for you at first, or does it come very naturally? And do you have any piece of advice for students who wanted to pursue that route, and what kind of suggestions would you give them to study or start off this research agenda?
So I kind of fell into distributed system somewhat randomly. I wanted to do an internship to improve my German. And there was a opportunity to study at Max Planck in Germany for 3 months. And I had to select which area of research I was interested in. I'd never done research, never thought about doing a PhD. And PL seemed kind of theoretical. Computer architecture seemed kind of applied, and distributed system kind of felt like a nice in-between. And we just learned about vector clocks in class, and I thought that was a cool concept. So I selected distributed systems. And I did an internship that summer, and that summer was the most fun I've had for pretty much any summer. I just loved what I did. And it so happened that our internship project was about georeplication and transactions. And I kind of never looked back. And I think, I wish I had a better answer than this, in that I had, carefully thought through this reasoning, and I didn't, honestly. If we hadn't learned about vector clocks that week, maybe I would have chosen PL. I think what I do find is that what I enjoy looking back is I like abstractions. I like thinking about how the relationship between theory and systems. So I like having a theorem, I like having a proof, but I also like building it out. And so I think distributed systems gives you that the ability to do both. Like, you have to write algorithms, you have to write proofs, you have to model things, but you also need to implement it, and you also need to evaluate it and show that your new theory helps in practice. So I think for me, that's what I like, and that's probably why I like distributed systems in the first place. So maybe rather than an area, I think the type of research that the type of problems that you enjoy solving will probably drive you towards the research. Because I think for me, it's more about being in that happy middle. And that's probably more important to me than it is to solve a particular problem. I got interested in privacy, I still got interested in law and regulation. And so I think that's what I'm trying to drive some of my research towards, because these are problems that I enjoy. But my hunch is that the problems I still get the most excited about are the ones that have some kind of theory and some kind of large-scale system implementation to back up the theory. And in terms of getting involved and getting, interested in the area, I think honestly reading some of the papers, like going through OSDI, SOSP, Eurosys, and SDI, and picking a topic and just reading the last, 5 papers in that area, and then looking at their references and going back, is probably the best way. To me, literature review, like spending 2 or 3 months just reading papers until you start noticing that you're seeing citations that you've already seen, is the best way to do it. This is more of a European style, where I think you spend the first 3 or 4 months just reading, and that's not how it works in the US, where people encourage you to do something and to get started on a project. But it worked for me, and I enjoyed sort of starting from the last papers that were published at the main conferences and kind of going back. And at some point, you start going full circle, where you realize, oh, I've actually seen this. And it gives you an idea for the space. That's probably a good.
That's really interesting. I wonder, like, how American students do they rely on courses and then they kind of forward track what happens in the area, like the vice versa?
I think certainly courses help. So I think I think a lot of PhD students have prelims as well, but you have to read some of the main papers in the area, and you have an exam. So that's another way to look at the main papers. And I think students learn as they go. So if they're building something, usually with a more senior PhD student, might be running experiments, or they might be building a small part of it, then they'll have to read a few papers about that topic, and then they'll start from there. But I personally enjoyed having a broad view of the space first before I started doing anything. It's a question of preference.
Nice. That's very interesting to hear, especially the serendipity of choosing the topic. It resonates with me quite well. So, what we also wanted to ask you is about Berkeley as a collaborative space. So, Berkeley is particularly known for so many collaborations happening, and like Skylab is one of those kind of big umbrella projects. And then everyone is kind of looking to read this big visional papers about like, here's a view for the cloud, here's a view for serverless, and so on. So how do you find this environment, and like, what is your perspective on like pros and cons of collaboration? And what would you have an advice for assistant professors, of course, just starting their career?
So I think I have no interest in working alone, or particularly wanting to push my own research agenda and having my own fiefdom or whatnot. And so I really wanted to work with people, and that's actually what I loved in the startup, where we're all working together. And I think that was probably one of the big criteria for me for when I was choosing schools. So there were places that told me, oh, maybe it's best not to collaborate too much before tenure, because we want to make sure that you're independent and that you can do work alone. And there were schools that were like, well, we couldn't care less. I don't think I've ever co-authored, like single authored a paper. And every school talks about collaboration. Every school talks about how collaborative they are, but there are some schools where it's just a non-issue. And where people would sort of smirk when I asked them, does this matter? And be like, of course it doesn't. We just want you to do good work, and people will stop working with you if you're not contributing. So assuming that they keep working with you, then that's fine. And I think reading through the lines, that made a big difference for me. So it did influence my choice. And I think Berkeley was one where they didn't, as long as you did good work, they didn't particularly care whether it was with whom it was. And that was something that I really emphasized. Like, I don't, every project that I had right now, it's either started out of a collaboration, or I actually reached out to someone, another faculty that I thought, like, whose expertise would help the project. So I don't think I want to have a single author paper. The downside of that is that obviously people may ask, oh, I'm still collaborating with my advisor, for example, because there's one PhD student that started when I graduated. So I've kind of been informally advising him. And some of the main research ideas that I had finishing my PhD, he's been following through. And so, the flip side is people might say, oh, is that Natasha's work, or is that Lorenzo Alvisi's work? And the advice you normally get is don't collaborate with your advisor. So you have to be careful. You have to be careful that you don't only collaborate with one person, and maybe you don't always collaborate with senior people, just to make sure you have your own identity. My hunch is that in most schools, and Berkeley's quite good about giving people tenure, in the sense that I think they view tenure as the norm and not the exception. And that's a relief. I think doing good work is more important. Doing work that you find interesting is more important than worrying about whether tenure will happen. Like, I think if there's a senior faculty that seems to be taking advantage of you because you're doing all the work and they're taking all the credit, okay, that's a red flag. If you're only working with your PhD advisor, that's a red flag. But if you're working with your PhD advisor a little bit, you're working with some colleagues of your school a little bit, you're working with external colleagues a little bit, and then maybe you have one project that just happens to be your own because the PhD student isn't collaborating with, or it's with anyone at that time, that's fine. I think if you become an assistant professor, it means that you've been doing good academic work, and there's no reason why you should stop. And just create the environment in which you thrive, and that's probably good enough to assume it's going to be okay. I mean, at the end of the day, if you don't get tenure, you'll just get an interesting job in industry, being paid more, working less. And honestly, if we're doing systems, the work will be equally interesting. So my advice is do the work that you find interesting, and then in the environment that you think is best for you, and don't worry about whether that's going to get you tenure. Because if you don't, then it'll have been a fun 5 years, and you'll be in industry equally happy. At least that's my approach.
Yeah.
And could you tell us, like, how do you choose collaborators? Like, is there like you said, red flags, or like it's simple, or you need to like take a look at some particular characteristics?
I think obviously your colleagues in your own school make a lot of sense, because they're the people you're going to be talking to a lot. And I think at Berkeley, people were very generous with me, in the sense that I noticed that people said, oh, you have this expertise in X, we're working on this project, can we get you interested? Because, and I did the reverse. So that was one easy way. And that kind of happened organically. It was during COVID, so it was harder for it to happen organically, but it still did. The other type of collaboration, which I thought was good, is when you graduate, all your PhD friends are also going to be graduating. And so these are people that you maybe went to grad school with, and now professors in different schools. And that's actually a good source. That's been a great source of collaboration for me. Because suddenly you're not in the same school, you're not advisors, you're equal. Neither one is more senior, but there are people that you've known for 6 or 7 years that you know whether you work well with. So they've been a great source of collaboration as well, where I've kind of basically worked with my friends if their expertise was relevant to the project. So there's one project I'm doing now that I'm doing with someone that I went to grad school with 5 years ago, but I knew his expertise was relevant. There was someone who reached out to me, again, went to grad school with, who thought my expertise was relevant. And so I think your graduate school colleagues are also a great source of collaboration, because you know them already. It's good for each other's CV, and it's probably just fun as well.
Thank you so much for sharing regarding a philosophy of choosing collaborators. And I definitely agree that working with friends can be fun. And I think one of the other questions we want to move on, or the topic we want to move on to, is about managing other collaborative relationships in your PhD, because as we all know, like advisor and advisee relationships is probably one of the most important relationship in the PhD career. So what's the tips for making this relationship most fruitful for both of you?
I think being honest with your advisor is probably one of the things I would recommend most. It's really hard to do, but at the end of the day, your advisor wants your success, because their success depends on your success. And so trying to be as honest as possible with your advisor, and that's really hard to do, it's probably good. Like, there's no benefit to pretending that you did work 1 week if you didn't, or that you understood a concept if you didn't, to your advisor, because 1, they're going to realize, 2, they're going to want to help you, right? Like, if you're not feeling well, for example, because of the world, because of personal reasons, trying to pretend that things are okay with your advisor isn't going to be helpful, because then they can't help you. Like, if you're stuck on a problem, trying to pretend that you're not stuck, or that you're making progress, is probably not good, because that means that they're not going to help you. They're not going to be able to help you. I'd rather know if my PhD student just didn't do any work because they were tired or because they procrastinated, than they did do work and they just struggled. And because it means that I can help them differently. I think your advisor is your best supporter, and they're going to be the one that writes you the letter that they want you to succeed. Like, I desperately want my PhD students to succeed because that's how I'm going to make my own career. At the same time, obviously, your advisor has slightly different interests than you. Like, you're not completely aligned. I would like to get tenure. That's, broadly speaking and simplifying, my goal. Once I become tenure, my goal will be different. And so I think keeping that in mind is also important. From a prestige perspective, I may want my students to go to get the best faculty jobs, right? The most prestigious schools and faculty. So that means I may want them to stay longer, because by the time they're in their year 5 or year 6, they're highly productive, right? So they're great for me. It's great for them to stay longer. That might not be what they want. They may just want to join Google, or they may want to return to their home country and in a school that is maybe less prestigious, but they'll be happier there because they'll be next to family, or they'll be in the most prestigious school in their country. Or I may have my own bias about what prestige means. So I think it's good to remember that even though your advisor is your best supporter, inevitably their interests aren't completely aligned with yours. So I think those are the main 2 things I would say in terms of managing your advisor. The other thing is learning how to manage your advisor is probably good. I think one of my advisors, I discovered I would get a reply if I sent him an email between 11 p.m. and 11:45 p.m. That's when I discovered that he would reply. So I started scheduling my emails. Even if I send them at 9 p.m. or 6 p.m., I would schedule my email so that it would arrive at 11:10. And that worked. Or, I found out that the best way to get a response to get something done was to format it a certain way or come to their door. Advisors have quirks. And so learning how to work with those quirks and trying to use them I wouldn't say use them to your advantage, but trying to get to know them, get to know what works for them, and then figure out how you can use that information to have a more effective relationship with them is also probably important.
This resonates with me quite well, because I feel like every advisor has their interface to work with. Like, different people have completely different ways of communication and when they're effective, and when you can as a PhD student, you can take the most advantage of, for example, this 20-30 minutes you're lucky to get like on Wednesday morning, and that's it. So a lot depends on the PhD student, whether they would take advantage or it would be just another report.
And I mean, from an advising perspective, what I'm discovering is the hardest is that every PhD student is different. And every PhD student reacts well or badly to different things. Some like harsh feedback, some like only positive feedback, some view help as something negative, some view help as something positive but don't ask for it. And so as an advisor, you also have to figure out the right interface to your PhD students. So I think it goes both ways. And in some ways, trying to be honest is about what, having this conversation about what works. It's a difficult conversation to have. It's uncomfortable, but it's probably a worthy conversation to have.
This is an excellent advice. And sometimes it's a bit difficult to evaluate your progress as a PhD student. So because everyone works on a different problem, and sometimes like you're working on the project, it's been a year, like it's still like not clear whether you can make a publication of what you're working, what you're working on, and like maybe you do produce a lot of charts and like a lot of inspiring data, but how at the end like you can reflect on your performance as a PhD student, or maybe how can you help as a PhD advisor to figure out like where the students stand and how to help them with that?
Good question. I think everyone's PhD looks very different, and people progress at different speeds. I think my first author publication was in year 4 of my PhD. So I got in like a couple of second author papers or third author papers before that, but my first author publication was in 2016, and I started in 2012. So that was a long time. And part of it was because I had to learn how to build a large-scale system on my own. And so, that paper I did exclusively on my own. And so I had to learn everything, and I had to make every possible mistake in doing it. And that was okay. And then the next 2 or 3 papers came relatively more quickly. Some people have the opposite experience where they have a first author paper pretty quickly early on. If they have an advisor that is supportive, maybe they're working with a senior student, or they had more guidance, or maybe they just got lucky, and then they struggle for the next paper because suddenly the advisor's a bit more hands-off and they have to find their own idea, and that's a little hard because they haven't had that to deal with that period of uncertainty, or everything has come easy to them because they did well in undergrad, they did a PhD, and first year of grad school, second year of grad school was also kind of a continuation of undergrad, and suddenly they're stuck. Like, oh, now I have to find something that's actually my idea, and then they struggle. And so for the next 2 years, they don't do much. So I think as long as you feel like I don't know exactly how to assess the progress of PhD students. I'm still learning, and it's going to look very different for everyone, but I am noticing that I can see some of my students making progress, and progress it's going to look very different for every one of them. Some of them is being more comfortable dealing with uncertainty, or being more comfortable pushing and going into the unknown. Some of them it's becoming better communicators. So I can't quite put my finger with it, but I can kind of see who's making more progress in my eye, and who's struggling a little bit. And it doesn't look the same for everyone, if that makes sense. I think from the perspective of a PhD student, comparing yourself to other people is going to like depress you tremendously, because you're going to focus on what everyone else is doing well and not on what they're not doing. So, you're going to look at someone having 4 papers, but they didn't do as much outreach as you did, or maybe all of those 4 papers was because they had a tenure track advisor that did a lot of the work for them, whereas you were completely on your own and only have 1 paper, or maybe they just got lucky, and in 2 years' time they'll struggle. And so you tend to focus on the good of everyone else as opposed to the holes in their CV. And so you kind of construct this arbitrary perfect person that is necessarily going to be better than you, because you're just picking out the best of everyone else. And we're in systems, it takes time. We don't have a huge amount of conferences, and so sometimes just 2 years to build a system plus maybe a year to get the paper accepted, and you're 3 years in. That feels like a very long time with nothing. And other people might get papers more quickly because they just got lucky, or because their implementation required less work. It's normal. As an advisor, I think you get a sense for what students are doing, like the progress that students are making, because you see them change day to day. I think as long as you see that change, in whichever axes, I guess someone has to improve, then that's probably okay. In terms of the project making progress, that's a harder question. I'm not sure I know yet when to give up on something. Or, you know, how long between exploration and actually building. I think I'm still figuring this out when it's not me doing the research, but it's my students.
Yeah, that's a very, very good point. In my experience, it also depends a lot on the environment in the lab. So like competitive or collaborative environment in the lab. So can make it either better or worse.
I mean, everyone will always look better. I think it's a rule. I got people commenting, like when people were applying for faculty positions, I would be at Cornell and like I would see their CV or like their first slide and I'd be like, I am never going to do this. I am never going to get to that stage. And then I had PhD students when I was applying. Faculty all said, you know, how did you get to this? I will never get that. And honestly, sometimes I would look at their CV and think that theirs was better. And so I think everyone else will always look better. And so comparing yourself is just a recipe for spending many anxious hours.
Yeah,
And-
these are good points. Thanks so much for sharing all these insights with us. And yeah, we've learned so much from your expertise and also experience. And maybe we have a question regarding the research taste that I would like to ask, which is, there's a lot of debate about when choosing a research topic, should we go about more fundamental or like incremental system research? And I think as a researcher, it's really important to show that you can distinguish the trends from the hype and really do fundamental contributions to the whole field. But when you are kind of starting your career as a student or maybe a junior faculty, how would you balance off projects with different risks and rewards? And how would you manage your time and resources most effectively considering the research agenda? Thank you.
That's a good question. I think everyone's fundamental research is incremental to someone else. So many people have said, oh, you know, this is just incremental. And some people have said, oh, this is radically novel. And it's also just a question of taste, of like what other people think about that research area. So I think that's one thing, is that incremental or fundamentally radically novel is also in the eye of the beholder. I think what is probably a good rule of thumb is don't try to go for the minimal publishable unit. So what I mean by that is, if you see a quick fix, then don't go for the quick fix. Try to make sure that you can't do any better. If you really have no idea how to improve on a solution beyond that quick fix, then maybe that's good enough for a paper. But don't try and, whatever idea you have, and your ideas will probably become more and more radically novel as you build up your own intuition. Like your first idea is unlikely to be revolutionary. It's probably going to be some issue with a system that you found, and that you can build a new system that solves that issue. And then as you build taste for that research, then your next projects are going to become a bit bolder, maybe. But I think I don't know if I have a good answer about like radically new different approaches versus incremental research, like more incremental. But I do know that like trying to avoid the minimal publishable units is the best, because no matter how many papers you have, if you're applying for a faculty job, they will ask you for your 3 best papers. And you better be sure that like those 3 papers are good. And I think some of them might just be like, oh, it's a very, if you're working on hardware or RDMA, for example, then maybe you would observe something very specific about RDMA, and you built it, but you really like implemented it well, evaluated the hell out of it, And so while your idea might be incremental, but it's just how that area is, you did a really good job at it. And so people will respect that. Or if you're in a space that's a bit more new, then you might be able to make more innovative, more sort of radically different propositions. But then you also need to make sure that you evaluate it well. You've already thought through, justified why you departed from the state of the art. So I think regardless of whether you do incremental versus radically different, that might also just depend on the space in which you're in. But I think making sure that you don't go for the minimal publishable unit. So whatever idea you have, make sure that someone else isn't going to improve on it by just reading the paper for 5 seconds, for 10 minutes. If there's a better paper that you could have written, you should write that paper. Within reason, right? You're not going to solve everything in one paper, but I think making sure that there isn't you're not just getting lazy, or you're not just trying to optimize for the number of publications, but for the quality of the publications you're submitting. I think that's probably the more concrete advice I can give. Because that's what you're going to get judged on. So people can have like 20 Sigmod or maybe 10 SOSP papers sometimes. But you see sometimes the CPA people that have like many papers, but they don't actually necessarily end up doing well on the job market because none of these papers kind of shine on their own. And I think that's something that is good to keep in mind.
These are really great advice. Thank you so much, Natasha. I think I believe all of the students who are starting their research or maybe in the middle of their PhD or even they are targeting for job markets, they will benefit a lot from your insights about how to think about research problems thoroughly. And I think we are almost at the end of our time, so I would like to leave some room for the audience to see whether they have any questions to ask. And if the audience has questions, you can either post on Slido or you can directly send them on Zoom. Let me quickly check the questions. Okay, I think there are some general questions. Maybe we can post that previously audience are curious about. So for example, I think doing a PhD is like a long marathon. So how do you motivate yourself or your student when they get stuck? And how do you find the optimal stopping point? Like when do you think it's the right time to change gears? And how do you balance perseverance and flexibility?
I think if you get stuck, for me, the two things that worked personally is one, to keep regular working hours, and two, honestly, to have friends. So for me, especially when I was coding, it didn't matter. But when I was trying to find an idea or trying to, think of a problem, making sure I was in the lab by 9 and leaving by 6 was actually the way that I knew I was making progress. Because I knew that at least, even if it felt like I hadn't made progress, I could force myself to do something from 9 to 6, whether it was reading papers, whether it was trying to come up with an algorithm. It really helped me to have that structure because it gave me the confidence that at least I was making, I had to have done something. It might not have been concrete. The result might not have been concrete, but it felt like I had done something. So for me, the regular working schedule was especially important when I was in the thinking about a project phase or in the stuck phase. If I was just coding, it didn't really matter because I could measure my progress through lines of code or graphs or performance results. So that was one thing that really helped me in terms of figuring out when to stop. I think as you keep thinking about a problem, then you're going to start coming up with reasons why it can work and reasons why it can't work. Right? Like if it's not working, then you're going to start thinking, okay, well, there's two reasons. One, at some point you're going to start becoming fed up about the project. If your like mental health is being affected, if you're just like thinking about quitting, or if you just don't want to touch the project anymore, then honestly, maybe that's a good time to, and you've spent, 2 months on it or 3 months on it, and you just really don't want to deal with it anymore, then maybe that's a good time to switch. Maybe it's a good time to switch to something for a little bit of time, like help another PhD student with their project, or work on another project that you have, right? Being excited about something is important. So if you're feeling so like stressed out about that, then you're just not able to see anything, then maybe that's just a good time to give up, at least momentarily. And then you'll come refreshed again, maybe. I think there should be, the more you think about a problem, the more you're going to find in every solution that doesn't work, you're going to learn something. So I think when the list of reasons why it doesn't work is becoming larger than the reasons why it might work, then maybe it's time to call it a day. But I think there should always be a scientific reason in some ways, like, for why it's not going to work. And I think as you fail, you're always learning something.
Mm.
And then I don't have a bulletproof answer. Like there's things I probably worked too long on, there's things I probably missed out on because I switched. But I think there should be a scientific, especially when you're starting a PhD, there should be a scientific reason for why you legitimately believe this is not going to work. You should be able to argue it to your advisor so that you're not just giving up because it's hard. You're giving up because you actually legitimately believe it's not going to work. That would be my best half answer.
Can advisors or mentors help this as well?
I think so. But I think other PhD students can also help because they've been through it more recently. I think the danger with advisors, advisors can also help. I think the danger with advisors is they don't see how personally this is affecting you. So if it's causing you to be miserable, then maybe that's a good reason to stop. They have we have 10, 12 projects going on at the time. And so it doesn't feel, one of them isn't going super well, and there's going to be 5 others that are, and vice versa. So it feels a little different. They may not be aware that a year has passed, whereas you're very much aware that a year has passed. So I think that PhD students, you talk to them, you think why this is going well, why this is not working, and so on. Just a good brainstorming resource. Your colleagues are your best brainstorming resources. And I think for your advisor, in general, if you don't believe something is going to work, or you do believe something is going to work, you should be able to articulate it. You should be able to have a concrete set of 5 or 6 reasons why you believe it's worth continuing, or you believe, conversely, it's not worth continuing. And I think just trying to write those reasons down and then having a conversation will help it keep, scientific, if that makes sense. But I think it is worth remembering that your advisor is less involved and invested in that particular project. And so it's also about how you feel about it.
This is a really good perspective. So, thank you, Natasha. So our time is almost up. So this was a really interesting discussion, and I really appreciated how we compared both the PhD perspective and junior advisor perspective, general advisor perspective, the part of the relationship and the research. So that was really, really insightful, and I'm sure our audience learned a lot from this. So we're really, really happy to have you here. Thank you for coming.
Thanks for having me.
Thank you so much.
Have a nice day, evening, morning.
Okay, have a nice day.
Have a good day.
Yeah. Bye.
Everyone takes care.